Right, for Unit 7, we're going to be applying properties of exponents. So our first standard we're going to look at is exponent properties involving zero and negative numbers. Now, exponent zero sometimes can be a little bit confusing. So in words, it says a to the 0 power is 1. We might think, well, anything to the 0 power should be 0, but it's not. All right, so let me give you an example. Let's say I had 10 to the 3rd power. Well, that's 10 times 10 times 10. That's 1,000, right? 10 to the 2nd power, 10 times 10 is 100. 10 to the 1st power, right, is just 10. Now, if we follow our pattern here, right, so our exponent's 3, 2, 1, our next exponent would be 0, and everything I'm doing here, I'm dividing by 10 or I'm dropping a 0, okay? All right, now when we look at later on at another rule that we'll get to, I'll also show you another example of where that also works and why the pattern is what it is. But sometimes in math, we have things that maybe don't make sense, right? What do you mean I have 0 tens? Why is that not 0? Okay, but sometimes in math, we have things that we have to do in order to have a pattern keep going and work with a rule or a definition. So algebraically, a to the 0 power is 1, so right, it looked like that. Okay, and then example, 5 to the 0 power would equal 1. Our second rule there is with negative exponents. Okay, so a to the negative n power is the reciprocal of a to the n power. Okay, right, so again, if we think about like 5 to the 3rd power, right, if I write that as a fraction, that'd be over 1. Okay, so the reciprocal of that would be 1 over 5 to the 3rd, right, which is equal to 5 to the negative 3rd power. Okay, so I'll do something like a to the negative n power is equal to 1 over a to the positive n power. Okay, so in reality, when we have a negative exponent, right, if I turn the exponent positive, I've got to put it in the denominator, right? I get the reciprocal, right? The 1 in the numerator, which we don't, or denominator, sorry, which we don't see because we don't put 1 into denominator typically, right? Would become the numerator, right? And we take that positive and put it in the bottom. And we'll look at some examples here to maybe clarify that a little bit better. But so if I had something like 3 to the negative 2nd power, right, I'd make that 3 to the positive 2nd and make its reciprocal, 1 over 3 to the positive 2nd. All right, and then our third one is basically saying the same thing. A to the n power is the reciprocal of a to the negative n power. Okay, so a to the n is equal to 1 over a to the negative n. Okay, so like 4 to the 3rd is equal to 1 over 4 to the negative 3rd. All right, so basically it's just, oops, let me write that a little better there. Kind of, those two are just kind of the opposite of each other. There we go. Okay. All right, now let's look at some examples down here. Let me scroll over a little bit. So m to the 0 power, again, our rule is anything to the 0 power is 1. So m to the 0 power is going to be equal to 1. All right. 4 to the 0 power is going to be equal to 1. All right. So again, anything to 0 power, with the exception of 0, right, is going to be 1. All right. All right. X to the negative 4th. All right. So again, our rule is if I have a negative exponent, right, and I turn it positive, I make its reciprocal. So again, think of this as like this. X to the negative 4th over 1, right? I'm going to do the reciprocal and change the exponent to positive. So that'd be 1 over x to the 4th. Okay. 4 to the negative 3rd. Again, think of that as over 1. I'm going to zoom in here a little bit. There we go. So think of that as reciprocal, 1 over 4 to the 3rd, which we can also think of as 1 over 64. Okay, so 4 to the negative 3rd is 1/64. All right, 1 over x to the negative 2nd. All right, so we're basically kind of undoing what we did here, right? I want the reciprocal, and my exponent goes from negative to positive. So you can kind of think of it as every time you move it from the numerator to the denominator, or in this case, the denominator to the numerator, we've got to do the opposite of that exponent. Okay, so this becomes x to the positive 2nd over 1. So there's the reciprocal. We change the sign from negative to positive, which is more simply just x squared. Okay. If we look at this one, 1 over 4 to the negative third. Right, again, we do the reciprocal, 4 to the positive third over 1, or more simply, 4 to the third, or 64. All right? So again, it's almost like a switch. You change the sign of the exponent, it's got to move to the other part of the fraction. Right? If it's in the numerator, you move it to the denominator. If it's in the denominator, you move it to the numerator. There we go. Now, these are a little bit more complex because they got a little bit more going on here, but let's just break it down. So I've got 2 times x to the 0 power. Okay. Well, we know x to the 0 power is 1, so let's just write this 2 times 1. Okay. And then y to the negative second. Right, it's going to become 1 over y to the positive second. All right. And let's combine all that together. So my numerator is 2 times 1 is simply 2. And my denominator, I have y to the second power. So it'd simplify down to that. Right? So just break it into its individual parts. Okay. And then our last one here, let's see, w to the 0 power is going to be 1. All right. Negative 3x to the negative fifth. All right. Now, we want to separate this out. And sometimes this is a mistake students will make when first learning this stuff. Okay. The exponent is only on the x. All right. You can think of it like that, negative 3 times x to the negative fifth. Okay. So the negative 3 is going to stay the same. It's still going to be negative 3. X to the negative fifth is going to be 1 over x to the positive fifth. Okay. And again, we have that w times 0 is 1. Okay. So we can think of it like that. All right. Now, my numerator is negative 3 times 1 would be, I'm going to come up here and write this, negative 3. My bottom might have x to the fifth power. Okay. So again, the negative 3 doesn't go down into the denominator because the exponent is only on the variable. Okay. So when you apply that rule, again, we do the reciprocal. X to the negative fifth over 1 becomes 1 over x to the positive fifth. Right? Like we see there, the negative 3 stays there. Okay, so these longer ones, you just want to break up into their individual parts, use your exponent rules to simplify those, and then put it back together into one overall answer like we see there. Okay. All right, here we go in 3, 2, 1. All right, we're going to look at a couple more properties with exponents, and this is exponent properties with products. Okay, so you've got the product of powers property. It's kind of a mouthful to say there. Says bases must be, so we're dealing with situations where bases are the same. Okay, and if they are, you simply add the exponents. Okay, so an example of this, come over here and then we'll fill in the table. Let's say I had like 5 to the third power times 5 to the second power, right? Okay, so the bases are the same. Well, what's that really mean? Well, 5 to the third power means 5 times 5 times 5, right? 5 to the second power means 5 times 5, right? Well, if I gave you 5 times 5 times 5 times 5 times 5, and I said write that out, that's simply 5 to the fifth power. You notice that we add the exponents there. I've got 3 5s and 2 5s. Together, that's 5 5s. A common mistake I'll see students go is a couple things. They'll either go, well, that's equal to 5 to the sixth power, because they'll want to multiply the exponents, and that's incorrect. Okay. Or sometimes I'll see students go, well, 3 and 2 make 5, but then they'll multiply the bases and go 5 and 5 is 25. Again, that's vastly different. That's 5 25s multiplied together, right? If I write this out the long way, 5 to the third is 3 5s, 5 to the second is 2 5s. We're just multiplying that all together, right? If I just combine that kind of into one single thing there, we just have 5 5s. That's 5 to the fifth power. All right, so when we have that rule, when we have this bases the same, you add those exponents. Okay, so an example might be 5, let's use the one we did, 5 to the third times 5 to the second equals 5 to the fifth. Okay, a to the x times a to the y equals a to the x plus y power. We just add those exponents. All right. Again, bases have to be the same. I can't go 6 to the third times 4 to the fifth and add exponents. It's got to be the same base. Okay. Power of products property. Okay. This time, when we have power of products, we multiply the exponents. And I'll give you an example here of that. Okay. So let's say let me get rid of this. Let's say I had 5 to the second power, and I wanted to square that. Okay. Well, what that means is 5 to the second power times 5 to the second power, right? And we just found out that means we add our exponents, right? So that's 5 to the fourth. Well, 2 times 2 is 4. Okay. Let's look at another example. Let's say I had 3 to the third, and I want to take that to the fourth power. Well, that's 3 to the third times 3 to the third times 3 to the third times 3 to the third, right? Fourth power, 4 of them. Well, my rule with exponents, same base, I add my exponent. Right? 3 plus 3 plus 3 plus 3 equals 12. So our shortcut is simply multiply our exponents. Okay? So 3 to the third to the fourth power is 3 to the 12th power. Okay? A to the fifth power squared equals a to the 10th power. Right? So we multiply our exponents. Right? Multiply our exponents in this case. So that's when we have the power of a power. All right, so a to the x raised to the y power equals a to the xy power. 3 squared to the third power would equal 3 to the sixth power. Right? We multiply those exponents. Okay, and power of a product property says find the power of each factor and multiply. So you can see our example there, xy, whole thing to the third power equals x to the third power times y to the third power. So it's almost like the distributive property in a way. Razor's being a little slow. So if I had xy, right, to the third, well, that means x times y times x times y times x times y. Right? And if I rearrange that, I got 3 x's, 3 y's, right? So x to the third, y to the third. Okay, right? Another way you can think about that is, right, there's no exponent there, but if we don't have an exponent, it means it's to the first power. Well, what's our rule of powers of powers? We multiply those, right? So x to the first times 3, y to the first times 3, right? So it look like that. Okay. All right, let's look at some examples here. There we go. So we've got a to the fifth. Let me zoom back in. A to the fifth times a squared. Okay, well, our rule is if I'm multiplying exponents, that's like 5 a's and 2 a's being multiplied. Well, together that's 7 a's, right? We add our exponents together. So that's a to the seventh. Okay. Our second one, m to the fourth raised to the fifth power. Well, that's like 5m to the fourth. M to the fourth times m to the fourth times m to the fourth and so on, right? So we're not adding them anymore. We're going to multiply them. Okay. We've got 5 groups of 4, so that's 20. So m to the 20th power. All right, just multiply your exponents. Okay, and then x to the negative third raised to the negative second power. Again, our rule is multiply your exponents. So negative 3 times negative 2 is positive 6. Positive 6. All right. Fourth one there, p to the negative second times the fourth power. Again, our rule is multiply that together. So that's p to the negative eighth. Right? And if we want to, we can simplify that as 1 over p to the eighth. Okay. And then so those are all kind of one step following your rules. Now, when we get to this next part, right, we've got to kind of combine some of those rules together. So 2y to the third times 3x to the negative fourth squared. Let's deal with, let's zoom in on this one a little bit. Let's deal with the second part first. Because the first part, right, this we can't really do anything with. Okay, it's just 2y to the third power for now. Okay. Now, a couple things to remember. 3 times x to the negative fourth. Remember, 3 has its own exponent, right, of 1. Okay. So we're going to apply the squared to both of those. All right. So 3 to the first squared. Again, our rule isn't power of a power, we multiply. So that's 3 squared. X to the negative fourth squared would be x to the negative eighth. Okay. Now we got to start putting some parts together. All right. So combining like terms. First off, 3 squared is 9, right? And then I've also have the 2. So I'm going to put those together. 2 times 9. All right. So that's that. That's that. Okay. All right. X to the negative eighth, I'm going to list as 1 over x to the positive eighth power. So we're going to apply that that rule we learned on the previous page. Okay. And then y to the third. Okay. And then I want to combine all that together. So in my numerator, and remember, think of these as all being over 1. My numerator, I've got 2 times 9 is 18, times 1 is 18, times y to the third. So I've got 18 y to the third power. And on the bottom, 1 times 1 times 1 times x to the eighth power would be x to the eighth power. Okay. Now I could write that. You might sometimes see this written like this. Okay. We're going to try and get rid of these negative exponents when possible. And rewrite it like that, but sometimes you'll see them written both ways. All right. But again, we got to kind of take that step by step, kind of break it apart, apply our rules, and then put it back together. All right. So we'd end up with that. Okay. And then our last one here, kind of the same idea. Let's start with the first part this time. So 8 times w to the negative fifth, right? So I'm going to make that 1 over w to the positive fifth. Okay. And then I've got 2 to the first power to the fourth power. So our rule is power of power, multiply those. So that's 2 to the fourth power. And then w to the third to the fourth power, again, multiply those, w to the 12th. Okay. So now I want to go through and start simplifying. All right. So I've got my 8. 2 to the fourth is 16. All right. So put my numbers together. Okay. And then I've got, I'm going to do this a little bit differently. Let me go back and erase this just to show you. Okay, and this maybe sometimes is best to keep it as a negative because we'll see what happens. So we've got w to the negative fifth times w to the 12th. Okay. Now 8 times 16, we can simplify. That's going to be 128 if my math's right. Yep. And then our rule, again, we're multiplying exponents. Our rule is we add those. So negative 5 plus 12 is 7. Okay. So we end up with our final answer of 128 w to the 7th power. Okay. So we've taken this and we've simplified it down into a much easier thing to deal with. All right. And again, right, sometimes you kind of have to look ahead. So I initially wrote that as a fraction before I realized that I'd have to combine my w's. So, the negative thing, if you kind of wait till the end, right, this first one here, I knew there wasn't any other x's, so I changed it right away. Here, right, I kind of left it as a negative first because I had to do some combining with the other w. Okay. All right. So again, follow your rules, right? The ones we get probably mixed up the most are going to be when we add and when we multiply, right? We add exponents. Remember, when you're multiplying same basis, we multiply the exponents with a power of a power, right? So we can see the difference there. 5 to the third times 5 squared, 5 to the fifth. Add your exponents. Oops. And then 3 squared to the third power, right? That's 3 squared, 3 squared, 3 squared. So it's really, we're adding 2 plus 2 plus 2, right? So we want to multiply those to get 3 to the 6th. Okay. Just refer back to the table as you need help with that. Okay.